Why do we diagonalize matrices? Is there a good reason for it, or are just mathematicians into torturing linear algebra students? A little bit of both, but let me give you a couple of good reasons. Consider this linear map. The diagonalization of that matrix is this other matrix. What does that represent in terms of the linear map? If you look at the linear map geometrically, that represents a reflection about the y equals x line. And for that operation, there are two special lines. There is the y equals x line, which is preserved, so the vector 1, 1 is sent to itself, and there is the perpendicular line, the line that is y equals minus x, such that those vectors are reversed. They are sent to their opposite. So the vector minus 1, 1 is sent to the vector 1, minus 1. That means that the vector 1, 1 is an eigenvector with eigenvalue 1, and the vector minus 1, 1 is an eigenvector with eigenvalue minus 1. And that's the reason why the diagonalization of this matrix is that one, and it's a matrix where this linear map is much easier to understand, and it's giving me essential information about that linear map and the transformation. Here's a completely different question. Suppose A is that matrix. Can you compute a to the 10th power, so a times a times a 10 times? This, again, it's not just an exercise to confuse students. It's important because these powers of matrices come up when we try to solve certain differential equations. You can try to look at the pattern of powers of a, and there is nothing that I can tell that I can predict what a to the 5 is, never mind a to the 10th. But diagonalizing helps. The diagonalization of the original matrix is minus 1, 0, 0, 2. And that means that there is a matrix B, which is what we call the change of basis matrix, such that the original matrix is B times the diagonal matrix times B inverse. And moreover, powers of a diagonal matrix are easy to compute, and B times D times B inverse times itself, the B inverse and B cancel out, so a power of a matrix of this form is just B times D squared times E inverse, and similarly, a high power of A will be a high power of this, which is also just amounts to a high power of D, which is easy to compute. Hence, when I want to compute a to the 10, and if I already know how to diagonalize A, all I have to do is multiply B times D, the diagonal matrix to the 10th power, times B inverse. And the diagonal matrix to the 10th power will be minus 1 to the 10, which is 1, and 2 to the 10, which is 2 to the 10. And this is now easy to compute. And now the answer is that a to the 10 is this matrix. And in fact, I can do the same thing for any power of A and compute them very quickly and very easily using the diagonalization of A.